Okay, in the last class, we have seen the magnetic field due to a current through a circular loop. Okay, we have seen that through a circular loop, the magnetic field at the center of the circular loop will be very strong. It can be further made stronger by increasing the number of turns of the coil or circular loop, or you can increase the number of turns of wire, okay, in the circular loop, and hence increase the strength of the magnetic field at the center of the circular loop. Now we will see magnetic field due to a current in a solenoid. Okay, first we will see the definition of a solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the form of a cylinder is called a solenoid. I will repeat the definition once again. A coil of many circular turns of insulated copper wire wrapped closely in the form of a cylinder is called a solenoid. So, a solenoid is a coil of many circular turns of insulated copper wire which are wrapped closely in the form of a cylinder. Okay, and the pattern of magnetic field lines around a current carrying solenoid looks similar to that of a bar magnet. Okay, we will see the solenoid, the diagram of solenoid. See here, solenoid is a circular coil of many turns of insulated copper wire which are wrapped closely in the form of a cylinder. You can see this is in the form of cylinder. This is a coil of circular coil of insulated copper wire which are wrapped closely in the form of a cylinder. So this is a solenoid. A solenoid is connected to a battery through a key K. And when current flows through this solenoid, the magnetic field around it will be just like a bar magnet. And the magnetic field lines inside the solenoid, they will be parallel. The magnetic field lines inside the solenoid will be parallel. So the magnetic field inside a solenoid is very strong and very uniform. Uniform means it is the same at all points. One end of the solenoid behaves as a north pole, the other end behaves as a south pole. This diagram is there on page number 229. Okay, you can see that diagram and draw in your fair book. Okay, so the magnetic field inside a solenoid is uniform and strong. Uniform means it remains the same everywhere. It does not increase from left to right or it does not decrease from right to left. It is the same everywhere, means it is uniform. You get a uniform strong magnetic field inside a solenoid. Okay. And what is a solenoid? A solenoid is a circular coil of insulated copper wire which is wrapped closely in the form of a cylinder. When current flows through a solenoid, the magnetic field inside the solenoid is very strong and it is uniform. One end of the solenoid behaves as a north pole, the other end behaves as a south pole. Now, since we get a strong uniform magnetic field inside a solenoid, so we get a strong uniform magnetic field inside a solenoid. So, a solenoid can be used to magnetize a soft iron core, or it can be used to magnetize a piece of magnetic material like a soft iron core. So, what is done is, this is a solenoid, that is a circular coil of insulated copper wire which is wound very closely in the form of a cylinder. Inside this cylindrical core, a soft iron core is placed. See here, I have written a soft iron core is placed, And when current flows through this solenoid, the soft iron core which is placed inside the solenoid will act like a magnet, will behave like a magnet. And the magnet so produced is called an electromagnet. Okay, the magnet so produced is called an electromagnet. Okay, so what is done? What happens? A very strong uniform magnetic field is there inside the current carrying solenoid. So inside the solenoid, a piece of magnetic material like a soft iron core is kept. Current is passed through the solenoid and the soft iron core starts behaving like a magnet. It behaves like a temporary magnet. The magnet so produced is called an electromagnet. What is it called? It is called an electromagnet. So it is called an electromagnet. So you all can write down these notes. I will repeat what I have taught you right now once again. First we saw what is a solenoid. A solenoid is a coil of many circular turns of insulated copper wire which is wound closely or which is wrapped closely in the form of a cylinder. Okay, and it is connected to a battery through a key. Okay, and the magnetic field lines around a solenoid will be similar to that of a bar magnet. But inside the solenoid, the magnetic field lines will be parallel, which means that the magnetic field inside the solenoid is very strong and uniform. Uniform means it is same at all the points. It does not increase or decrease inside the solenoid as we move from left to right or right to left. Okay, and this strong magnetic field which is produced inside the solenoid can be used to magnetize a piece of magnetic material. Here what is done is a soft iron core can be kept inside the solenoid. This is a solenoid in the form of a cylinder. Inside its core you can place one soft iron piece or soft iron core. And when current is passed through the solenoid, because of the uniform field which is produced inside the solenoid, the soft iron core becomes a magnet temporarily. And the magnet so produced is called an electromagnet. Okay. And one end of the solenoid behaves as a north pole, the other end behaves as a south pole. So the strong magnetic field produced inside a solenoid is uniform, and a solenoid can be used to magnetize a piece of magnetic material like soft iron or nickel or cobalt. And when a piece of soft iron is placed inside a solenoid, it behaves like a magnet. And the magnet so produced is called an electromagnet. Okay, now one more thing you have to see that I have told you already. The magnetic field inside a solenoid is uniform. It does not change from left to right. It does not decrease from right to left. It is uniform at all the points inside the solenoid. Take down these notes in your fair.